As you know, my name is Kyneton and welcome to another system design class. Today we are going to be talking about WhatsApp system design, and there are just 6 steps to follow to design a messaging application. So this applies to WhatsApp or Facebook Messenger or any other chatting application. There are 6 steps to follow. In the previous class, I did design of TikTok, system design of TikTok, and there are also 6 steps to follow in this case. But for messaging application, these 6 steps are a bit different. So the first one is identify functional requirements. Step 2, identify non-functional requirements. Number 3, identify system components. Number 4, identify your choice of data storage. Number 5, message processing flow or message routing. And number 6, implement selected requirements. So these are the 6 steps to follow. We are going to be going through them one by one right now. So let's get started. So let's start from the first one, identify functional requirements. There are many functional requirements for a message application, and they include, so let's write out as we go. 1, functional requirements. So the first one, messages should be able to be sent and received. Send, please. And number 2, users should be able to create a group. Create group. Now you need to clarify this requirement in case, because they can be actually many of them. You want to clarify with your interviewer which ones you want to focus on. Then we also have group messaging. Group messaging, and then we also have delivery sent, delivery and read receipt. So we have send, delivery and read receipt. Okay. So these are notifications. When the user sends a message, you want to get a tick mark that says it's been sent. When the user, let me take a red pen, and when the message is delivered, you want to get another message, that message is another notification. And when it is read, you have a blue tick. So it's going to be a blue, change it from green or gray to blue. So these are also features you need to have in mind. The question you also want to clarify, is it necessary to store messages? So let's just write it down. Let me take out this pen. I'm going to write it as a question mark. So store messages. Okay. So in case your interviewer wants you to carry on with these very store messages, you also want to mention it. And we also want to talk about images. Images to be sent and received, or media, let's call it media images, or videos or voice notes. And we also have last seen, and we also have voice. So a lot of messaging applications at this point support voice messages. So once you list out this, you want to identify the key features or the key requirement. For me, I'll go for, this is the main one. We have group and this. Then from this 4 downwards, you want to clarify with your interviewer. So at this point, let's move on to the next step, which is non-functional requirement. I think there should be a few of them. So let me just say non-functional requirements. Non-functional requirements. Just clean up this a little bit, of course you understand it. So one is message should be durable, right? Message should not be lost, all right? So I'm going to write it here, durability. And the next one is an efficient protocol. Efficient protocol So at this point, your interviewer might actually stop you and ask you, what do you think about the protocols? HTTP, FTP, and other protocols. So basically, we are going to be using WebSockets. WebSockets is for messaging, for end-to-end communications between two peers. And the next one is we have durability. We have we also have encryption, and we also should have scalable. So scalability means if there is surge in traffic, let's say during festive seasons in December or sometime, there is surge in number of messages that goes out, the number of group messages that goes out. You also want to be able to handle this item. So have functional requirements, non-functional requirements, and the next thing we are going to be talking about is system components. Now pay attention to this because your architecture should derive from the system components you've already identified. So let's now outline our system components. So system components, I think there should be a number of them. So the first one, we should have gateway. So each device, each messaging device, maybe a phone or a tablet, must be connected to a gateway for it to be able to send message to the next item. There should be a message server. Okay, so this from mobile device to gateway, then to message server. In the message server, we should have something called session manager. And we should also have, I think I listed them here. We should have, to support durability, we need to store messages that are not delivered so that they can be redelivered. So we can have message queue, and we should also have message DB. So we are going to be explaining how these things work. And we should also have group message service. I don't know if you can see my board at this point, not sure. So I have message DB. So I'm going to continue from here. So we have group message. Can you see the board? I think so. Service. And we should also have load balancers because we can have several devices connected to certain gateway, or you can have the gateways connected to several instances of the message server. So we should also clearly have a load balancer. We have a message buffer. So message buffer is needed at the client side to be able to hold outgoing and incoming messages. So we have and if we are going to be handling images, we're also going to need some kind of blob storage. Now, the next thing is identify your choice of database. Now, this is kind of something you have to clarify with your interviewer because you want to decide whether to store images or not, or handle images or not. Images have to be stored. This time, it has to be in some blob store, not a relational database. So that's, I think we are moving on to the next part now, which is data storage. So we need a way to hold a message that has not been delivered so that it could be delivered later on. And we also need a blob store to be able to store our media. Then the next thing now we are going to be talking about is the image processing flow. So I'll give you a few seconds to take a look at this. Maybe I'm going to just write out this. We have blob store, can be S3, and we also have message DB. You can use, let's say, a key value because you're only storing the ID of the receiver and the message. So when the receiver is not found, the message is stored there. So you can use a key value database, possibly DynamoDB, or maybe MongoDB or something related. And I think this is, we have message queue as well. can be used, in this case, it can be some kind of cache, can be implemented to hold the message queues in the client side. So are we forgetting anything? And we also need, here I forgot. So we have something called process table. Process table, which is also the same as, let me see, connections cache. So this is the same as connections. So connections cache, this process table holds all the messages, all the clients that are connected at a time, and the process ID handling the process that is actually exchanging the messages they send. Let's now get into the actual architecture of how this works, and then we proceed from there. So now we have two mobile devices. We call them client A and client B. Client A wants to send some message to client B. So the first thing we want to identify is, let's identify the payload of this message. So this message is going to contain the message and the client, right? So we have the message and the client. So maybe I'm going to just write it here, MSG and client ID. Okay, hope you can see it. So this is a message. The message, the content of the message, and also the client that sent it. So this guy wants to send it to this guy. Of course, you can't go directly. So the first thing, the first component we listed is a gateway. So we have this connected to a gateway, GW1. So this gateway is responsible for routing the messages to the particular client. So it actually does not do any much processing, but it just handles getting the message and sending back information. So again, all the clients will be connected to a gateway. So this GW1, this is GW2, and this is GW1. So this is the first item on the line. So I'm going to say here, the message goes here, the arrow is pointing back this time. Now this guy originates this message and sends it to the gateway. The gateway is going to receive it and is going to forward it to the session manager. So, but there are some details I'm going to add later on. So it's going to forward it to, let's call this, everything here is the message server, but in this case, this particular component is the session manager. So it's going to forward this message all the way to the session manager, and the client ID 1, and client ID 2. Right? So this message contains who is sending this message and who is receiving this message. So once the session manager gets it, it's going to check and look if it finds gateway 2. It finds, okay, client ID is at gateway 2. So that is why we now have what is called the process table. So it's going to look up this table PID and client. Okay? I hope this is clear. So let me just write it a bit clearly. PID and client. Right? So once the session manager receives this message, it's going to start a session for this communication and it's going to update the PID for this guy who originates this message. So in this case, we start a session with a process ID of 1 and the client's ID of, the process ID of 1, the client is A, right? Right? And it's going to check, okay, receiver is client 2, is going to check. Let's assume that this client B is connected to this server, and it means that there should be a process for it right here. So the session manager is going to look up the process table, which is a connections cache. This should be a cache. And it's going to find client B, and is going to route that message to client B. So this is what happens when a message is sent successfully. It's as simple as this. But this also looks up this table. So let's just add this arrow here. Question: when this guy is not connected, for instance, so when this guy is not connected here, what happens? The session manager is going to look at the sessions table and is going to see that the session, the ID client 2 is not connected. It's not going to throw away this message because we said that the message should be durable. That's where storage comes in. So there is a DB to store pending messages right here. So this DB stores pending messages, and I'm going to just do this. So we have the client, it has a table, a simple table. It has CID, client ID, and the message. So in this case, the message that was to be delivered to client B is not found. That message is going to be stored here, and the entry is going to be made. The client is B, and that message has to be stored here. So at this point, we've achieved something called durability because this message is not lost. Now, when client B connects to this to the server, of course, this is inside the message server. When client B connects through the gateway to the session manager or to the message server, then it's going to update PID. A process will be started, PID 2, and client B. At the same time, once it connects, it's also going to check. Once it connects, the session manager is also going to pull this table for any messages for the newly connected client. And if it finds it, it's going to pull it out and forward it to the client. So in this way, we've achieved durability. Message is not lost. So let's talk about send receipt, delivery receipt, and write receipt. So this guy would like to know if the message has been sent. So when this client A sends a message and the session manager gets it, session manager is going to send back an acknowledgement that the message has been sent. So this is going to get the message sent. Once the message comes from the client and arrives in the session manager, the message server here is going to get the first tick is going to come right there. The second one, which is delivery receipt, if the session manager finds this client B in the PID and forwards this message to the gateway, the gateway notifies that it has received it, and then there will be a delivery receipt. And if the user at this point, this client here, opens and reads this message, this gateway 2 is notified and a read receipt is sent. If the message is stuck in this place, then we can only have send receipt. Once the message is pulled out from this the pending message database or table, then if it's pulled out and sent, we now have delivery receipt. Now there's another feature we're talking about, high scalability, assuming there are so many people wanting to send messages at the same time. So in that case, you want to highlight that the message server here, you can actually add load balancers at this point, and then these are microservices. These are also microservices. You can scale them easily. So you can load balance messages coming from here. Actually, these are the microservices which are running on several instances. Let's now talk about group messages. Now, group messages is now delegated to another component called the group message service or the group message handler. So the group message handler is this component here, which I call group message handler. So there is a group message handler, right? Once a user creates a group, that information gets onto the group message handler. Of course, the group message handler also is connected to the session manager as well. So all these items here make up the message server, but now we split them into parts so that the ball is not cluttered up. So once you create a group, we have the group message handler gets notified about the name of the group and the list of the members in the group. That happens right here. Now when a group member sends a message, when a group member or someone sends a message to the group, of course I'm not sure you can send a message to a group from outside the group. So you have to be right inside the group to send a message to the group. So once a member of the group sends a message to the group message handler is going to pick up the list of recipients or the list of members of the group and trigger exactly the same process we have here. So it's simply going to iterate each member of the group and follow the same procedure we have here to send the messages. So the question comes when we have a message and it has to go to, let's say, thousands of people. So one thing that message applications do is to restrict number of items in a group to avoid so much load on the server. So maybe to 200 or to 500 or thereabout. But even in that case, if this message contains media and there are so many people in the group that has to receive, we can actually send this message in batches. So we can have a batch processor here. Batch processor as part of the group message handler. So we're going to say BP. So this batch processor here is going to handle taking chunks of these messages and sending it. Maybe 10 recipients send, 10 recipients send in batches. And also it can be done in parallel. So this is how to handle group messaging. The final feature I would like to talk about is the last scene, right? The last scene. Now we want to have the mobile device here, the client here, want to know when someone was last seen, right? So the messaging server should be able to provide that information even without this guy being connected. So how do we do it? Because at the end, when this message 2 or client 2 is not connected to the server, how then does it get information about this client? The simple way is to use a component called the heartbeat handler. So the heartbeat handler, I actually explained all this in my website, so you can actually read it in my website. You can find the link in the description box below, and you'll be able to understand how it works. So we have something called the heartbeat handler. So it's gonna be here. It's also connected to the message server. So it's gonna be client CLI, and basically it's another data cache provided or database as well, and the time stamp, or we can just call it heartbeat, HB. So how does it work? Once a client is connected to the session manager, it enters a heartbeat into the heartbeat cache or this heartbeat table, the client and the time. Every 3 seconds is going to update it. Now it goes from 1 to 2, or every 5 seconds, depending on how frequently you have to do it. So it keeps updating it, it keeps updating, like this guy keeps updating 1102, and every like periodically is updated. So this data is maintained as part of the message server. So anytime a user wants the last thing, when did I last see client B? It goes and checks. This is the last time we got a heartbeat from client B, and it sends it back. So I think this is basically all. Let me see if we have any other thing to talk about. Okay, we have handling media. So how do we handle media? Again, this is also delegated to, we talked about, I want to just clarify something. We talked about WebSockets. For this exchange, round-trip exchange happens by WebSockets. But if you want to send a media, you don't send the media via WebSockets, because a media is something you send one time from time to time. So it's not as frequently sent as a message. So we don't handle it in the same channel, on the same socket as text messages. And therefore, when a media or an image comes in, it's going to be routed to a message handler that uploads this media. It's going to be routed to a media handler that uploads this message to a blob storage, and then updates the session manager with the URL of this blob store, right? As well as the recipient. So what is going to happen in this case is we have this. So I don't know if this is visible from here. Okay, I don't have any more space here. So we have the media coming from here is going to be sent by HTTP, all right? And it contains the client that sent it, the client that is receiving it, and once the media handler places it in the blob, it's going to update this message payload with the URL of this message. And then what goes to client 1, the recipient, is the URL of this message in the blob storage. And client 1 can now fetch it from the blob storage. So this is basically how we handle media. Everything I've explained is outlined step by step in my website, and the link in the description box below. There's a short architecture, I like a minimized architecture. There's also a more detailed architecture I've provided. So please check the link, and also try to leave me a comment if you have any challenges or you need more explanation on how this message handling works. So I'm going to be stopping here, and I want to recommend you consider subscribing to my channel, and also like this video, maybe share it around, connect with me on my social network profile, because this is how I actually like to help many software engineers and any other programmers or IT professionals to gain the skills they need. So please connect with me on Facebook, on Instagram, or LinkedIn, anywhere you connect with me. I'll be happy to reach out to you. For now, I remain Tyson the Tech Pro, and I'm always there for you.